Okay, good morning, people. Anybody that ever watches my things. We are now from an undisclosed place in Canada. I skipped out on the United States for personal family reasons, but my timing seems to have been impeccable because, wow. Anyways, let's stay away from politics as best I can, though it's hard because it does affect actual people. Today, let's look at the unreasonable awesomeness of math and how it seems to map onto reality so well, and how maybe we should even accept that and take that further. So, we're going to start with the number line. Here's the number line. Boop, da, boop, da, boop. Five, six, seven, 8. So of course it goes on forever, infinity, and this is going to get sort of hard to see at some point, but such is the way things go. Now, here's our number line, and here is 1. And what I'm going to talk about a little bit about is sort of reciprocity. That is this idea that, and how it relates to the holographic universe. So there's 1. Unity, single thing, single-arity. Okay, here's 1. There's 2. The reciprocal of 2, so 1 is 1 over 1. The reciprocal of there's 2. The reciprocal of 2 is 1 over 2. 3 over 1, 1 over 3. So notice that essentially this single-arity is the mirror that everything gets reflected off of. 2 becomes a half, 3 becomes a third, 4 becomes a quarter, 5 becomes a fifth, 6 becomes a sixth, 7 becomes a seventh, until notice how these lines have to get tighter and tighter and tighter and tighter and tighter as we go inwards. The numerical pressure, so to speak, increases. Whereas here, you go from 1 to a half, it's 1, 2. You double it to 4. It spreads out. Double it to 8. Numerically, the distance gets greater. But proportionally, we're just doubling. And here, half, a quarter, an eighth, a 16th, it gets tighter and tighter. Rather than getting spread out, it gets tighter and tighter on this side. This is the holographic universe in a sort of like straight up number form. Okay, every number out here, infinity, and 1 over 0. There's some debate about this, but functionally, this is the way it works, right? As you get larger, 1,000, reciprocal would be 1 over 1,000. Infinity is 1 divided by infinity. Oops. But it's also 1 divided by 0, which is a strange sort of infolding on itself. So we are now going to step away from the numerical. That was just so we understand this sort of reciprocity, where everything outside can be mirrored inside. 1 is the mirror plane here. 1 over 1 is the mirror plane. Every number outside here has its inverse reciprocal inside of 1, inside of the singularity. Okay, now we're going to take this into a 2-dimensional field. And this is what's called the circle and its inversion. If you haven't heard about it or know about it, it's incredibly powerful, and I consider it the best model for our universe, really. So let's create a circle. We're going to call this a circle. And there's our center point. This is one of sorts. This is our mirror plane. This is 0. And way off the screen where we can't even see is infinity because it's so far away. Now, there's this trick that you can do with the circle and its inversion, where let's say you have a little object and you have a shape in here, but you want to get a different perspective of it. So you flip it inside out on the other side of the circle, on the other side of the singularity. And the way this works is, let's say we take a point here, the half point, draw a line like this. Like this. And you draw lines out to here. Then you mark the tangent angle here, which would be someplace here. And the same over here. There we go. So this A has its reciprocal over there, A. We move in closer here, or even here, let's say. Draw this little line. Then mark the tangents. And over here. Something like that. There we go. So every point inside of this is the inverse of a point out here someplace. Now, let's just think about that in the holographic universe, right? Everything out here is mirrored in here, but the inverse. Okay, it is the inverse. So that means that if this is the matter universe, on the other side of the singularity of unity is the antimatter universe. Okay. Gravity pulls things towards here. This is our singularity. Things move. On the antimatter universe, things are also moved towards the singularity until you hit the surface, the event horizon. Now, that means everything gets drawn in the event horizon from both sides of the universe. My postulate of neutron decay cosmology is essentially that unity maps onto both 0 and infinity. When matter hits event horizon, it, through a trick of topology, reappears at the most distant place possible. Now, there is no true infinity. There's no zero energy. There's always quantum flux. There's always the cosmological constant. This is what contains our universe. There is a containment to our universe, though I believe it's temporal, not volumetric. Or it's energetic, not volumetric. In fact, you can go infinity distance, but wherever you are, what's important is that there will be an energy there. There will be some energy. This point and infinity are the same place. In the antimatter universe, things fall towards density. In the matter universe, things fall towards density. But when they hit the limit, the maximal density, there's an inversion topologically, and what was this neutron hits the event horizon. This neutron appears here, but it's also an anti-neutron. It's a neutron here and an anti-neutron in the antimatter universe. then it just does the journey again and again and again and again. We'll see what James Webb Telescope says long term, but it's looking more and more like galaxies all the way down, and galaxies all the way down, Big Bang really does not make sense. Whereas a steady state universe does make sense. And one of the interesting things is that since event horizons are essentially featureless, perfectly smooth, they add volume to the universe, but they don't add complexity to the universe. This might as well be a single neutron. It has no features. It is perfectly smooth. It is featureless. Therefore, it doesn't add complexity to the universe. It just adds volume to the universe. Okay, so this is one of the aspects of the unreasonable nature of how mathematics, and this is one of our guides. This is like, let's look at these essential functions in mathematics and how they map onto events in real world, in our universe. Now, as y'all know, or if you've watched any of my videos, in thinking about this, where there's like sort of like, here's a gravity flow toward the event horizon. Notice that these two are two halves of a circle, essentially. There's pi, pi, 2 pi. If I flip this over, that would form a closed surface, but this equation is actually, Shirley's surface is 4 pi, because you do one path, one loop on the outside, let's say. Here's a neutron. It takes up the most room possible. It decays, becomes hydrogen in deep, deep space, the least dense thing possible. It takes up the most volume. Then over time, gravity compresses it and 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 compresses it until it hits event horizon, this node. And then it doesn't reemerge as a neutron, what sort of does. Then you're now on the inside. And you do the same thing. You do a full loop on the inside. But the crazy thing about a single-sided surface is that if you're a neutron in the matter world, you are simultaneously an anti-neutron on the other side of the singularity, on the other side of space. I think I jumped ahead. It's early in the morning. Oh yes, I want to also display the cardioid, because these are just some shapes, but they're just shapes, but they're fundamental, simple shapes. And these simple shapes have significance in terms of real world, because math is unreasonably effective. Which way should I do it? Here's the cardioid. So this would be a circle. The cardioid goes like this. Okay. The cardioid displays all possible tangents. Here, it is basically flat. It is where the circle is. But here, we have this angle. Here, we have this angle. Here, we have this angle. And here, we are 90 degrees. This is maximal gravity. right there. So this cardioid shape can easily display any minimal to maximal range of any set of data. And you could find your place someplace on the range from minimal to maximal. Minimal, flattest, maximal, least flat. Neutron decay cosmology basically suggests that this maps onto this, that the neutron falls through space and time, because when you're moving at c and you're in the energy conditions of an event horizon, time and space now don't mean anything. They are all the same. You are everywhere at the same time. So now all it does is, oh well, we're not going to put you where there's the most energy, because that's the hardest place for you to penetrate. Quantum ground level. Here's an event horizon where it's the most energy. This is our maximal. And then down here is our minimal, where there's just the vacuum energy. That's where this emerges. The neutron falls through where there's only the vacuum energy, deepest space, deep voids of space. There the neutron decays, as neutrons do. Neutron decays into a proton and an electron. Neutrons decay into hydrogen gas. Things get compressed until a neutron stars. Then a neutron star inverts. What happens? Oh, all those neutrons get shot into space where they have enough room to become hydrogen again. This is the flow. It's really devastatingly, painfully simple, actually. Things get compressed. It's almost like in one of my other videos I think I mentioned, it's like almost like a jack-in-the-box. Here's the sprung out jack-in-the-box. The hydrogen in deepest space takes up the most room. It's completely, it's most expanded, its least dense form. But over time, gravity slowly shoves that jack-in-the-box back in the box. And here, the jack-in-the-box is finally shut up in the box. It's a neutron, the most dense form of matter. You could say proton, but there is no proton that doesn't have an electron. So if you don't include the electron cloud, you're kind of fooling yourself. The neutron is these two put back inside themselves, the jack-in-the-box, which then springs out and gets compressed, and springs out and gets compressed, and springs out and gets compressed. This is the path of the universe. This is the unreasonable effectiveness of mathematics. This is geometry. It's pretty much one of the most simple forms of geometry. You have a ball here and a ball here, and you take the string and you slowly wrap the string around this ball until this gets wrapped up inside, on top. Oop. And then it happens again. That's it. Okay, peace. Try and stay calm. I know things are crazy, especially down there in the United States. But let's just call this death throes of, monotheistic authoritarianism. Once we can get past this, everything will be rearranged, and hopefully we can get to a better place.